Okay, so some reactions will occur spontaneously. And so what we're going to do is we're going to look at an activity which is based on sort of like a gizmo, where I'll show you the results, we'll record the results, and then we'll discuss them for the first two examples, and then you'll look at the rest, or for the first example. I forget if it's the first one or first two. So with this activity, what we're going to do is we're going to take pieces of magnesium, copper, zinc, and silver and place them into solutions of magnesium ion, zinc ion, copper 2 ion, and silver ion. We're going to look to see if a chemical reaction occurs. So here we have our piece of magnesium solid in our solutions, and after we place it into the solutions, we can see that the electrodes got bigger. So that suggests to us that something was deposited onto it. We can see our color change, which is also another indication of a reaction occurring. So as a result, we have a reaction with our magnesium placed in each of the solutions. Okay, so we can see our copper had a reaction with silver ion and silver ion. We can take our zinc, and we can see that it has a reaction with both the silver ion and the copper 2 ion. And when we take our silver, we have no reaction with anything. Okay. Now, what do these observations mean? And so I've now just arranged it from magnesium, zinc, copper. We can see decrease in number of reactions. So if a reaction occurred, we can look at each of our reactions, right? So here I can see my zinc ion underwent reduction. My copper 2 ion underwent reduction, and my silver ion underwent reduction. With the zinc, my copper 2 ion underwent reduction, as did the silver. And finally there. So if we were to summarize our observations then and look at the number of reactions, we could see that my silver ion reacted with all of the metals. My magnesium ion reacted with none of them. Likewise, if we look at the reaction of the metals, we can see that the magnesium solid reacted with all of the ions in solution, while the silver reacted with none. So how can we use this to organize? Well, if we were to look at this and identify our strongest oxidizing agent, this would be our oxidizing agent that reacted with the most number of things, then it would be silver ion, because my silver ion reacted with all three. And if I was to identify my weakest oxidizing agent, it would be my magnesium ion, because it reacted with none of the metals. And we can see that copper reacted with less things than silver, but more than zinc, and zinc reacted. So therefore now I have them in a list of my strongest oxidizing agent to my weakest oxidizing agent. Likewise, we could rank our strongest reducing agent to our weakest reducing agent. You notice my strongest reducing agent goes at the bottom. My strongest reducing agent would be the metal that reacts with the most ions, in this case magnesium. My weakest reducing agent would be the metal that reacts with the least number of ions, which would be my silver. And then we have our other two in terms of the number of ions they react with. Well, I could take this and change it into half reactions. And so now I have a series of half reactions. And we saw that the half reaction of silver with copper occurred, and zinc and magnesium occurred, but magnesium ion with nothing did not occur. So let's take a look at our second activity. Okay? So we have our metals and we have our solutions. Okay? So you can pause the video here to record your observations where reactions took place. Okay. Hopefully your observations look like this. Okay. You can write your half reactions for each of the reactions, or sorry, your total net ionic equations for each of the reactions. Identify your reducing agents, your oxidizing agents. Okay. And as a result, we can see that our lead 2 ion acts as an oxidizing agent with all of the metals, so it must be the strongest oxidizing agent. Our iron 2 ion does not react as an oxidizing agent with any of the metals, so it must be our weakest oxidizing agent. Our nickel 2 ion reacts as a oxidizing agent with iron, but not with the other two. This suggests that it's a stronger oxidizing agent than iron 2, but weaker than lead. And because tin reacts with iron and nickel, but not lead, it suggests that it's a stronger oxidizing agent than iron or nickel, but weaker than lead. So as a result, if we write our half reactions for our reduction half reactions from our strongest to our weakest, we end up with this pattern. Okay, now activity 3, we'll place our metals in, record your observations. Okay, now for activity 4, we're going to place our metals into an acid. And when we do, these are our observations. We have bubbles with some of them, so you can record your observations. And now what you do is you'll use the techniques that we looked at for activity 1 and 2 to analyze the observations that you got for activity 3 and 4.